Oh, hello, everybody. We are live. My name is Robert Douglas. This is Deploy Friday, the webcast that you listen to or watch while deploying your production code on all of your production systems because it's Friday. It's the best day for that, as you know. I'm back after a 3-week vacation. I hope you enjoyed my colleague Chad Carlson in his role as your host. You might also note I got a haircut for the first time in a year. I put on the mask and risked the corona to go in and actually have a person-to-person interaction. And I hope you like my new look. Today, we're going to talk about the browser and its role in the new internet or Web 3.0. And we'll also talk a little bit about what that means. I have amazing guests with me today. I have with me Jeff Griffiths, who is the head of product at Fission.codes. And I have Bernhard Borges, who's the scientist and distributed engineer. A distributed engineer. I didn't read that the first time, but that's what's written here. Scientist and distributed engineer at Fluent Labs. Now, Bernhard, that raises all sorts of questions in my mind. If you are, how do you become a distributed engineer?
It's the next gen enterprise StarTech beaming technology that just fishes me out in many distributed pieces all over the world.
So that's amazing. Is that why we see only half of your face?
Yes, that's exactly.
That was like a beam me up, Scotty gone wrong.
Yes, exactly.
You're waiting for the other half, its eventual consistency of the rest of your body.
It's coming.
Okay.
Maybe by the end of the podcast, we're good.
Super. Okay, well, welcome and thank you for coming on the show. A little bit of background on this. It was a last-minute ordeal. We didn't get everybody on board to be on the show until like literally just right now. So if it sounds a little improvisatory, it's because it always is. We just improvise from top to bottom. But we're going to improvise about something really cool. Let's set the stage. We are going to talk about distributed apps, distributed web, and we're going to start from the point of view of 3 companies that and projects and open source communities that are active in that. So Jeff, would you please introduce yourself and also give us a little bit of a word about Fission.codes? Now, we've had Boris on the show. We've heard a little bit about that before, but for the people who might be new to that, what is Fission.codes? Who are you and what is Fission.codes?
Yeah, great. My name's Jeff Griffiths. I'm head of product at Fission. I've been at Fission for a little less than half a year, and I have a long history of working on the web, from open source tooling in the 2000s with a company called ActiveState through to I worked at Mozilla for a fairly long time on Firefox and things like Firefox extensions and Firefox developer tools. And I've also worked at AWS for a little while. And I joined Fission. I've known Boris for a really long time here in Vancouver, and I was really excited about his and Brooklyn's vision and also approach to really inverting a bunch of things around how web applications are made and hosted and scaled by putting more focus on the clients and thinking about the data that's created by applications in different ways. So in particular, Fission provides a distributed authentication system that allows users to have their own data encrypted at rest when it's stored in the cloud, and sort of removes the need for app developers to have hyperscale databases as step 2 in any project that they're gonna try and scale up. And those things are exciting to me because it allows different kinds of applications to be built and scaled and have the costs like paid off in different kinds of ways beyond just your AWS bill. So does that make any sense?
By some definition of the word sense, yes.
We can get into it.
You know, as an old school developer for monolithic, old school web apps, it seems funny that we can talk about web apps as like old school and being past tense, right? It's taken me a long time to get my head around some of those concepts. But let's move on to Bernhard. Bernhard, please introduce yourself, and also let's talk about Fluent a little bit and just put the pitch out there what you guys do as well.
All right, I'm Bernhard. I'm a scientist with Fluent. My background is in distributed systems, and since about 2016 blockchain. And I started at Fluent at the beginning of the year. Been following the project for a while, and coming from the blockchain side, it's become very apparent to me that in order to truly have decentralized solutions, the off-chain component needs to be decentralized as well. And that's where Fluent comes in. So Fluent is basically a protocol of decentralized compute. And the way we make this happen is through a stack that includes peer-to-peer networks that are built on libp2p, and that allows developers to host services that are WebAssembly interface type WebAssembly services, not bindgen, and run them. And then we have our own language called Aqua that basically allows you to program the network itself as well as compose applications from those services. So basically a set of distributed services on a peer-to-peer network gives you, depending on your workflow considerations expressed in Aqua, a decentralized application. And that brings all kind of interesting attributes to the table, from reuse, resilience, and how open source developers get compensated, as opposed to how big name cloud operators currently use open source. I mean, it's a very, very wide spectrum of issues that get resolved, and this is why I was really interested in the Fluent project. And as part of that is that by offloading compute onto a network, you really lower the access barriers, like a browser, to participate in digital activities, whether it's commerce, education, and communication. And but at the same time, moving the censorship gaps, if you will, or opportunities way out into the network, in which, as a peer-to-peer network, makes it nearly impossible. So you're basically doing two things. You're reducing hardware-based access and barriers, and you're increasing barriers to censorship. And in combination, we think this is really, really cool. And since we're compute, we work with storage like IPFS, for example, which is a decentralized peer-to-peer based storage, and many others, fission, ceramic, textile. There's a lot going on in the storage space as well. And that really, really allows you to start building decentralized applications that use blockchain, at least in my opinion, the way blockchain is supposed to be used, other than on the currency side, and that is to really store signed hashes as proofs of something. That's it in a nutshell.
Awesome, thank you. Okay, and I'm going to put the URL for Fission.codes up there retroactively for Jeff's sake, and in case anybody out there is checking these companies and projects out. All right, so let's summarize a little bit what I've heard and what I already know about both of these projects. So both of you have in common that you're interacting with storage at the IPFS level. Yep. And that's really interesting. Both of you are interested in the use of WebAssembly or WASM for compute. Bernhard's technology maybe even more so, because it sounds like a central, the marine component of aquamarine. That's great, because we've just had a show a few weeks back on WASM, where we tried to really go into what the capabilities are and the limitations are of that as a runtime and as a containerization and programming environment. So that was really interesting. And both of you are working for a world where that server that sits in the middle of everything, whether it's by Facebook or Amazon or whoever, where everybody talks to it, and that's how the web app works, where that kind of disappears and evaporates. And oftentimes you hear the word censorship, like Bernhard used, but also there are other benefits to decentralization, like just owning your own data and your own data privacy. There are also, for IPFS, arguments to be made for reaching parts of the world that have been kind of left behind by the infrastructure of the digital revolution, where you're not sitting as much on a backbone of the internet, where peer-to-peer file sharing is more efficient than always getting it from a centralized thing. Now, what role does the browser play in this? And I'm going to ask you to take this question, Jeff, because not only does Fission focus really heavily on the browser, okay? The Fission apps run in the browser. It makes the browser become the runtime and storage of the future. No servers, only browsers. It's browsers all the way down. So what role does the browser play in this new world, and what are the limitations now?
So the pithy answer, especially after PPK's article about Safari the other day, that you should check out.
Sorry, who's article?
PPK is he's a person that's written about the web a lot. So Google PPK, I forget what it stands for, but those are his initials. And he wrote, there's a meme going on right now that Safari is the new Internet Explorer, meaning that Safari is holding the web back in the same way the Internet Explorer 6 did in 2003, 2004. And so in that sense, if we want Fission to work everywhere, and so our tagline essentially is that Fission will work in browsers without extensions and on mobile. And that means that Chrome is so far ahead of Safari in terms of pushing device APIs and things like through their Project Fugu roadmap that they're doing to integrate more devices in Chrome, that Safari is really your base of limitations for what a browser can do. Browsers are really important to Fission because we have that ethic of working in the browser without extensions and on mobile. And so our limitation is whatever JavaScript can do right now and whatever cryptographic APIs can do right now, because one thing that we do is we have a privacy stack and an identity stack that encrypts everything for you on your behalf and then stores it in IPFS. And it does that by storing private keys in the browser using the Web Crypto API. This is something that we can do because we're using the very bleeding edge of Web Crypto standards and curves and new standards. Like the thing that we're dealing with this week is that we use the big int type. Do you know what the big int type in JavaScript is?
It's there was a size limit on ints to begin with, and then somebody realized that somebody needed bigger ones than those, and the big int is the one that gives you basically unlimited integers. Yeah, and so that is that seems like, why would you need a number that large? You're not going to count that high. Well, elliptical curve cryptography, which is what we use, the Edwards curve and other sort of related cryptographic techniques, they need really big numbers. That's all you really need to know about big int, is it's an absurdly large number, and we need some of those things in order to get to the point where we can have private keys and then store them. And what we've been struggling with for the last couple of weeks and working through is that if somebody randomly does, create React app and makes their React application, and they run their code and they're using web native and it uses big ints and everything works until they run it through the compile step that compiles everything back to ES5. And then ES5 barfs on these new standards that don't have an equivalent polyfill. And there's no equivalent polyfill for a big int because you just can't do it. And then the app runs in dev mode and then it fails in production. So that's great. So polyfills being the code that people write to compensate for browser differences and weaknesses. So you would need a polyfill for big int for Safari is the point that you were making. But it doesn't exist.
Yeah, most major browsers support big int. The only browser that doesn't really support big int right now is IE11.
Okay.
So it's actually the bundlers and the compilers. So Babel, if you take, Babel's settings and you set it so that you want to be really, really compatible back to 2015 or 2016 version of JavaScript, you run things through this compiler and it assumes that you want to run it on really old versions of browsers that don't have big int, even though all of them already do. And so the compiler, the build step, us building JavaScript from JavaScript for the web, is kind of failing us here, because old tool chains that don't adequately allow for newer features, and also the appearance. Usually polyfills work great. Polyfills are a great capability that we can do on the web to like bring things forward a bit if something's missing in a browser, and usually you can like do something in pure JavaScript that fills that bit in, or sands over the rough edges of API differences between Safari and Chrome and Firefox or whatever. But in this case, because of the nature of big int, you just can't polyfill it. And this is the first thing that I've heard of that you couldn't adequately polyfill. But it is the case, and we really need it. And cryptography is really important on the web for these things to continue to be private, as we see cryptographic standards to continue to be attacked by bad actors and researchers and whatnot. So yeah, that's yeah. And so
let me go ahead.
And I was just going to round that out, like, and so browsers and what browsers can do, and big moments like IE11 being completely set adrift next year by Microsoft and unsupported, really big moments for the web, and browsers, those capabilities keep getting better. And then really, Safari still seems to be Apple for their own reasons, and they're not very forthcoming about what their browser roadmap is the least capable front that's most widely distributed, because they have such a huge footprint on mobile. And so that's kind of the standard that we're building against. And then whatever Chrome does, if it gets adopted by other vendors, which it seems to be automatically get adopted by Microsoft for most things, that's like the bleeding edge that you could polyfill back from. And then Safari is the thing that will actually work in all browsers. That's kind of the situation we're in now.
Cool, thank you. So Bernhard, I realized I forgot to ask an important question up front for the sake of this discussion. Are you able to give me a definition of what Web3 actually is supposed to mean? Who came up with that term?
Well, I know it wasn't me who came up with the term, but I actually don't.
I'll help you out there. I mean, Protocol Labs uses that term. What do they mean?
From mine or our perspective, Web3 really is all about decentralization, and decentralization in the sense that you control your own data. Decentralization in the sense that you are not subject to control, outside control, state-sponsored or otherwise. You now this is probably a little bit more my definition, but I do believe it includes the capability of building blocks, sort of a Lego block approach to building decentralized applications. And I believe at the core of it is the very notion of peer-to-peer. So those are sort of to me, those are sort of the defining attributes, and then depending on the context, you can start filling in conversation pieces. But I really believe control of data and independence and access, permissionness, that to me are really, really big plays. And to me, those are the headliners of Web3.
Okay, thank you. I think that was an important building block of the conversation as well. And we originally conceived of this episode as talking about the Browser 3000 hackathon that Protocol Labs is currently sponsoring, and that both Fission and Fluent are participating in as sponsors. So for that reason, I'm going to start, but maybe either of you can help me fill the picture out. What is Protocol Labs? Who are they? What are they working on? I think that's kind of an important thing, since they're the organizers of that hackathon. So Protocol Labs have two very important pieces of technology that are central to this new web, or at least they think they will be, and they're, I think so, especially with, IPFS, which we've mentioned. I'll put that back up there again. IPFS being interplanetary file system. We've talked about that a little bit, but it's a decentralized way of storing and sharing files and data. takes concepts like content addressable to the very core of its being. And they also have something called Filecoin, which is a blockchain-based solution for storing, retrieving files, and incentivizing the verifiable storage and retrieval of those through payments, which happen on Ledger. So what am I missing? What else do Protocol Labs do? How do I typify their place in the constellation of Web3, since they're using the term?
I think that, so Protocol Labs has been around for a long time. It started in 2013, and then the project IPFS and Filecoin, and then the organization was founded by Juan Benet, who's the head of Protocol Labs. And the key difference between that and a lot of other things, like I'll think about this. I'll try to describe this in terms of how we host IPFS. So Fission hosts IPFS by running some servers and an S3 account. And so the servers are the IPFS interface, and the S3 account is where the stuff is actually stored. And so we don't have to run IPFS to host stuff online, but the IPFS layer in that scenario is basically fronting Amazon's S3 and making all the data that we store in S3 content addressable via a CID, or it's basically a large hash string, so that you can always find that content, and that we're pinning that content into our servers. And pinning is an interesting concept, where you're definitely saying, I definitely have this piece of data that's stored at this hash. But data could be pinned anywhere in the IPFS sort of universe, and we just happen to be pinning it, but it can be pinned in multiple places, and it can be distributed around. And so, for example, the example I like to use when explaining this to friends at parties is, imagine that you've got your data online and it's pinned for you, and you've got it stored somewhere, and you're on Earth, but you decide to travel to Mars, and you're gonna live on Mars, and that's what you're gonna do. And we're living in the future now, so that IPFS is like a interplanetary kind of thing, and so you get on your rocket ship, and you've decided that you're going to pin your data to Earth and Mars at the same time. And you take off in your 6-month journey in your rocket ship, and you go to Mars. And in the meantime, Earth has been hit by an asteroid. But because you pinned all your data to Mars, you arrive, and all of your cat gifts are still there. They're waiting for you, and you're really sad that Earth got hit by an asteroid, because that's terrible. But at least you've got your cat gifts to keep you company.
Yeah, I think those are your cat gift NFTs, by the way.
Yes. I've got a stoner cat story for later, but so that is the way that I describe how IPFS works in terms of pinning and distributing data around, and that it's the same address that you had for your cat gifts on Earth and Mars, but it's just you've pinned it in different parts of the IPFS ecosystem, and that means that it's available to you in different places. And some of those might be closer than others, and so the network might prefer to get the closest data to you.
Okay, so let's tie that to the browser. Okay, I get to Mars, I want to see my cat GIF. I open up Safari in the future, and I put what in the address bar?
So that would be an address for an internet gateway that bridges between HTTPS and IPFS, and that's a thing.
Is that a limitation in Web3? You need a intermediary to access files. I mean, right now, all those files could be on a server. You can go straight HTTP to S3. Why do we need IPFS in that if we can already get all those files, put them on a hard drive, take it to Mars with us in our pocket? So what's the browser's role in this? I mean, I see that as a limitation. Do you guys, Fission, Fluent, Protocol, do you guys, distributed web people, see that as a limitation? Is somebody working on that?
Yeah, people are definitely working on that. I'm aware of projects to integrate these kinds of things into browsers. There is a browser that supports the IPFS protocol handler, which is Brave. And And it's possible to do something in Firefox that supports that protocol handler, like IPFS : / and I think that Protocol Labs is in talks to expand browser support. But the bridge between, let's call it Web 2 and Web 3 right now is this gateway system or systems that people are running that basically take a Web 2 address and then go and look for the content addressable CID hash that's related to it, and they keep a map of those somewhere, and then try and find that pinned hash on the IPFS network. And so
who runs
that's
the biggest gateway right now?
I assume that Protocol does.
I think it's Cloudflare. I think they run it for Protocol.
Okay.
Do you guys know? I'm not sure, but I think there's irony there. There's huge irony that Cloudflare, which is a great company, but very proprietary and very centralized. Of course, their technology is about putting things around the world. So not centralized in the sense of physically centralized, but centralized in the power sense, like that it's all Cloudflare. They are the biggest gateway to the decentralized web between Web 2.0 and Web 3. I find that interesting and ironic.
I'm not sure if I find too much irony there, because Cloudflare is a distributed data company. They distribute things around their own proprietary data centers. They are participants in a group that we have called the IPFS Operators Group. They run IPFS and they do very interesting things with it. And we encourage them to open source those things whenever we talk to them. But the thing about distributed computing is, like, your stuff will always be on a computer somewhere, whether it's your computer that you control or somebody else's computer that you're renting space on or getting free space on. It's just how that is stored and whether it's intermingled into a giant table with every other person on Earth or not. And projects like Fission encrypt things at rest so that that's impossible. Whereas when you have when you're a Gmail user, all of your email is in a giant table with everybody else's email, I assume, but in a centralized way. But it's always like somebody else's computer, or maybe the computer in your pocket, or maybe the computer in your closet at home. But most consumers don't run computers in their closets at home. So it's going to be somebody else's computer, and it's more about how that data is stored and who has access to it and on whose behalf it's existing and being monetized or not monetized, more than whether it's in Cloudflare or not. Like, does that make sense?
Yeah, it does. So Bernhard, well, let's look at it from the Fluent's point of view. You're participating in a couple hackathons right now, as I understand, one of them being the one hosted by Protocol Labs. That's very much focused on the browser. What was the other hackathon that you mentioned?
ETH Global also has a hackathon, which is also sponsored by Protocol Labs.
Oh, okay. So they're both Protocol Labs, but they've got different focuses. Okay,
yeah.
Got it. Where, if I have a browser, how do I interact with Fluent's technology? What's the path there?
Well, I'll answer that in a very short period, but I want to go back to the contributions of Protocol Labs.
Oh yes, please.
So everything Jeff said, that obviously jives extremely well with what's happening. But to me, Protocol Labs has had a really profound effect on the entire Web3 space by developing libp2p. And even Ethereum 2.0 is now adopting libp2p over devp2p. And that's really, really significant for a variety of reasons. First of all, building peer-to-peer networks it's never been easy. Building distributed system has never been easy. But libp2p has really solidified the lowest level building block of how to build peer-to-peer, how to communicate over peer-to-peer, various gossip protocols, and I think that's really an achievement. The second part where I think Protocol Lab has really left its mark so far is through content addressability, all the standards around it, and all the efforts that are going on to build gateways, extend gateways, and IPNS, pushing IPNS, and the entire notion of linked data and the tools that come around it.
Stop, please. Hold your thought. Don't forget where you are in your train of thought. But please define content addressable and IPNS. Those are two terms that we haven't defined that we're using that are important.
Okay, so on the content addressability, basically, content is its own address, and you basically generate that from the content itself. It's a particular way of how you create a hash. Do we need to go into hash functions, which are basically you take a whole bunch of input and you run it through a function and you get something else out, which is very short, and you can go always from the big blob into the output function. It's always the same as long as nothing changes in the blob, but you can never go back from the output to reconstruct the blob. That's basically.
So I can say, hey, Bernhard, do you have that GHQ125XX55221341? And you can say yes, but nobody knows what that is.
Exactly. So, and this is where sort of HTTPS addressability in, sort of the Web 2 context becomes interesting, because yes, we can do HTTPS IPNS or IPFS and then load it in the browser. So, but it's only the content that's addressable itself. Now, an important aspect of content addressability is if you change the file, you have a different tag, you have a different CID, content identifier. So now you actually have a very easy way of detecting whether or not your content has been changed, has been in any way updated. And that has a lot of...
uses this, by the way, for anybody out there. Git hashes are exactly what we're talking about. A git commit is a content addressable state of your code.
Yes. And that really allows you to build very interesting layers on top of IPFS, where you basically can, for example, use an append log to track changes over your content, which is what Ceramic does, for example, with streams. And that opens up an entire new way of how you look at NoSQL, for example. And really that comes back down to content addressability and uniqueness of the content associated with the ID, the content ID, the CID, and the documentation of change, just like in Git, that ensues just by simply adhering to that standard. So in my opinion, those are some really, really profound advances Protocol Lab has brought to not just the Web3 space, but to the entire internet space, if you will, in general. And I think the second part is now you can start linking content using JSON linked documents, for example, which are basically give you directed acyclic graphs over your content, which makes an entire...
Did you just say directed acyclic graphs?
Yes.
I'm sorry. I'm sorry.
That's almost on par with Jeff talking about IPFS at parties, which he should never do.
Basically, it allows you to represent your content as a set of nodes and edges in a graph. So connections between your content, and you can then traverse that graph, that path, if you will, which is unique. So there's no duplicates in there, and start resolving connections between content components. So where it becomes important is now you can construct multi-file documents, for example, like a novel where every chapter is a file, and resolve that all automatically without ever having to tell anybody, this is chapter 1, chapter 2, chapter 3, chapter 4. You just basically, as part of the specification and the linked document that describes your graph, if you will, and on a sudden, whoever needs it can reconstruct that book according to whatever chapter version you wanted, without going through Git itself, without doing anything. It's literally free, and that's an amazing advance in how you compose higher level documents or content structures, and how you maintain them over time. Because maintenance is always the issue, right? I mean, this is where Git comes in many of the workflow management tools. Is how do you manage change? How do you stay on top of change? What do you do with change? And content addressability really helps developers and end users by providing concepts and tooling to hide the complexity of it from the end users and even the developers to a certain extent, while giving you very powerful, very succinct applications or an application blocks. So that was my take on where Protocol Labs comes in, and of course all this is
thank you.
is reflected in IPFS, Filecoin, etc., Fission, textile, ceramic, and on it goes.
Yeah.
So now, how does Fluent then build on that, and to bring it back to the browser? How are you dependent on the browser to get to the vision of where you think things are going?
Fundamentally, Fluent is compute, right? So I mean, if you need store as a developer, you bring it to the table. Of course, it makes sense to bring IPFS or Filecoin to the table, not say S3, right? I mean, you want to build decentralized. And you want to be in this peer-to-peer space, so obviously you would like to bring decentralized extensions to your application development process, like IPFS. We're accessible whichever way a developer needs to. It could be the browser, it doesn't have to be the browser. But the browser is a very interesting medium, in my opinion, because I don't know about you guys, but I'm sitting here with a big old MacBook Pro and a pretty powerful Android phone. And that's not how the majority of the people in the world access digital resources. And you look at much lower powered smartphones, and you look at much lower powered Chrome OS, for example, tablets. And so what part of the compute model is, you really lower your hardware cost, your hardware requirement to participate in digital activities, including streaming and codec updates, for example, JPEG processing, by taking it out of the browser and putting it on the peer-to-peer network. So of course now it's why Fluent or why a peer-to-peer network versus the Amazon cloud. I mean, it does the same thing. Well, it does, but it's not decentralized, and that the decentralization in our thinking is critical, because I mean, there's more from an application perspective. We're working with one company right now, unfortunately I can't name them, but they're building a huge decentralized chat application, and that's going to be pretty amazing. And that takes a very thin browser. You don't need these huge, I mean, Chrome is super powerful, but it's also a very big application, right? I mean, we're talking gigabytes. And if you ever look at whenever your fans go off and you look at on your computer and you look at your monitor, you see like 1,000, or no, I'm exaggerating, but you see an enormous number of threads running helper threads running for Google Chrome, right? So the more you can offload, the more the thinner the client becomes. And all of a sudden, cheap devices, including IoT devices, where a browser may not look what a browser looks today, and this is why Browser 3000 for us was interesting, is extremely capable of delivering really good experiences and digital participation to end users.
And what are the limitations of current browsers for you, from your perspective?
From my perspective, they're just very big, and there's a lot of opaqueness to it. If you install extensions, for example, who really does them? How are they audited? Where does my data go? Who's listening to what I'm using? And then that's just at the third-party plugin. And we all say, well, they should have known better. Why would you install it? I mean, I'm in the industry. I have a background in security, and yeah, I install stuff because I need it right now and there. I don't go through extensive audits. And I mean, one of the great things is that we have still a very increasingly vibrant open source community But at the same time is that the dependency stack of just about everything it touches runs really, really deep. So it's not just, so as an individual to audit these stacks, it's impossible, right? It's impossible. And by decomposing those stacks again into composable workflows, you actually can start tracing security and trust scores around individual building blocks. And that's really sort of where we're looking at it. And we, in our case, we have something that's not quite done, but it's developed actively. It's called Trust Graph, where you basically can manage trust associations subjectively for a really wide subnet of your components and even nodes in the network. And to me, those are advances that really help you take control of your data, not just the data you sort of knowingly put with others, but the data that's siphoned off your transactions without you even knowing. And by transaction, I mean literally like doing a Google search, for example, and you have something installed. And I think that's really important. And you look at, I mean, cryptocurrency is awesome, right? But at the same time, it enabled ransomware to unprecedented levels, and really like ignorant, and by ignorant I literally mean ignorant, not stupid, just like ignorant people are much more easily be taken advantage of the more they click on browser extensions, because there's nothing there. And again, like decomposing a lot of those applications and reconstructing the workflow that comprise these applications, which is where we see compute come in, really makes a difference, and or could make a difference.
All right.
Yeah, totally agree.
Amazing. So what is the distributed web going to look like for the end user in the future? Are we going to not visit Facebook anymore? How is it going to change the nature of the applications? Predict the future for me, guys. Come on.
One of the things that should be possible with a system like what we're working on is that the nature of the application does change, such that if you think about Facebook is mostly a server-side application, and it does ship like, you know, megabytes and megabytes of JavaScript, but that edge thing that you end up running in your phone in an app or whatever is pretty thin compared to the back end that's powering it, because it has to take custody of 1 billion people's data, literally, to say nothing of all the people on Instagram or whatever. But I think that it should be possible with things like libp2p and distributed communications protocols and an identity stack like what we're building at Fission that is designed to be a distributed identity. We have a concept sort of like CIDs, the content ID, called distributed ID for a person or things that are operating on that person's behalf. It's called a DID, and it's kind of like people should know what JWT tokens are, which is it's a JSON token that's used heavily in OAuth to assert identity when you're doing this or that or the other, when you're making API calls from your front end to your back end. And so DIDs are conceptually just like that, except they don't rely on a centralized server. They rely on a set of capabilities that they're allowed to do. And they work in a distributed way so that DID can be used without having to check back to see if the DID is valid on a centralized server. It's self-asserting, is what Brooke says all the time. What I would love to have happen from this platform is for someone at a hackathon to make an application and to put that on the web, and whether the protocols are IPFS or HTTPS or whatever, and for it to become extremely popular, and for 100,000 people the next day go like, this is the best thing ever, and they install it and they start running it. And for the developer of that application not to then have to worry about going and running to get a bunch of money to run massive RDS instances at AWS to store all the data for those 100,000 users. What instead would happen is that those users would be creating data that's stored on their behalf in their browsers, but also on the IPFS network. And the IPFS network's ability to scale would be tested here. And that's a distributed computing problem that we have to pay eventually, is scaling the IPFS network. And that's something we're very interested in working on. But you don't have to scale your own network and your own database servers and your own caches and your own load balancers. That happens with sort of a commons network of HTTPS gateways or not, IPNS stuff, or and then IPFS itself. All that data that's created by that 100,000 users that install this thing the next day, that just sort of gets soaked up by the network. And the developer is like, great, now I have 100,000 users. I can focus on making them happy and fixing the bugs, as opposed to just adding more and more RDS instances or paying AWS more and more MySQL RDS bills or whatever it is you have to do. And so I think that the developer story there is just like, don't worry about all this boring DevOps stuff. Let's abstract that. And worry instead about the application you're making and how it enables users and what problems users are having. It lets you be much more customer focused or user focused in that sense. And when people have to scale consumer applications to tens or hundreds of millions of users, so much is involved in the infrastructure of just getting that thing to run at all. So many things were created at Facebook for the first time just to scale Facebook, not to make Facebook users happier. And then so much of that stuff has to be paid by monetizing Facebook in a way that's actually working against the best interests of the users, which is the real problem. Just to pick on Facebook a little bit. Facebook is just one company that's doing this. They just happen to have the biggest user graph, but it could be anybody. It could be Google, or it could be whatever. Twitter.
Bernhard, out of curiosity, how does the Fluent network scale?
Okay, so Fluent network scales extremely well, horizontally and vertically, because while it is peer-to-peer, unlike blockchain, there is no global virtual machine that needs to compute state. So you basically, we don't have that, and resilience and redundancy is a developer choice, and basically deploying service components on one or more nodes in order to achieve parallelization or failover. So basically, as long as you can add nodes and services to nodes, you can scale. So the bottleneck fundamentally is not in the network. And
okay. Let me see if I understood what you just said. So if I'm a developer who's providing applications on the Fluent network, and those are coming into use, then I would still scale that in a traditional way by providing either bigger or more nodes for those applications to run in.
Right, and of course, ideally, the developer is not the node operator, right? I mean, there's an entire economic a layer to the whole thing where you start separating node operators from component developers from application developers, right? I mean,
so it's like Filecoin. There's an incentive for somebody to do something for me,
right? And that's
store has not compute. So run my node for me.
Right, that has not been formalized, but that's where we want to go, because I mean, in many respects, we don't want to be the operator of the Fluent network. We want to be a participant in the Fluent network, and we are working towards a DAO on that, because that's the whole point. So our monetization is going to be as a participant like everybody else, not as an operator. Otherwise, the whole thing is pointless.
Acronym alert, you said DAO. What's that?
Well, basically a decentralized community organization that as a community runs the network at some point.
Right. So my understanding of a DAO is that the rules for how that is run are formalized in what's known as a smart contract, basically, and lives on chain. Is that right?
Yes. I mean, you can do it off chain now. There are different ways of doing it now, but what the point is that the community basically votes and collaborates on how to run the network, how to upgrade the network, how to allocate resources within the network development and maintenance, and that there's no one central benign or otherwise dictator telling people what to do.
Right. So it's a democratized way of governance for computer programs, basically.
Basically, yeah.
Okay, thank you. I think that's important to go into in your description of where you're going with Fluent.
And can I just
Amazing.
add to Jeff's comments on existing big social media platforms? In many respects, there have been probably written hundreds of Facebook replacements, and some of them are really, really good. Why do they not take off? In my opinion, one of the biggest reasons is that big social media platforms have done a really good job of making the entry barriers to consumers or users very, very low, and the exit barriers extremely high. They basically silo your data, and that is it, and you can't get it out. You can't take all your chats or from your Facebook Messenger and take them somewhere else. Not unless Facebook wants you to do it. And I think that's been a real bane on alternatives succeeding. And this is actually where this entire thing about content addressability, IPFS, controlling your data, exposing your data not as the data itself, but the link to the data becomes really, really interesting. And I do believe as we as Web3 developers make it easier for users to participate, because you can't just throw a cryptographic key wallet at users and tell them, oh yeah, don't ever lose it because everything you have is gone. That just doesn't work. But if we are capable to provide a UX to Web3 that's equal or better than the Web2 experience in terms of personal responsibility and involvement, then I do believe big platforms that use data to hold users hostage are going to start to disappear.
I hope so.
I totally agree. And I also think that there's a real opportunity that's happening right now in that space. Like if you were thinking about Facebook about 10 years ago was really ascendant and had an intense density of usage. It has a very large user graph still. And then it has the WhatsApp user graph and it has the Instagram user graph. All these people and all the data that they have created over time. But Facebook is a generational thing. It's my generation and perhaps your generation that really heavily adopted it about 10 or 15 years ago, used it intensely for about 10 years. And it's been like increasingly in the Western world hollowed out is my sense of what's going on, that Facebook is a really less useful and less categories of things in your life. And I think that the pandemic has accelerated this in ways that are interesting. At the same time, Facebook was really smart to buy Instagram because it's really gone up and is very popular with a younger generation. But Facebook itself is mostly buy and sell stuff. You know, we stopped having events, so we stopped scheduling events on Facebook. And then people left Facebook. Like I have an entire, just speaking from my own experience, an entire group of people that I know that used to be on Facebook and aren't anymore. And you probably are experiencing the same thing. And so Facebook is no longer where everybody is for any one group of people, even the generation, the people in their like late 30s and 40s that really heavily adopted it back in that time. And so systems that are able to get people together and have people communicate that don't require the level of investment of a Facebook to get going and provide great experiences for groups of people like friends or colleagues or whatever. And like the Web 2 answer to this is obviously Discord. Discord is really popular. Those kinds of systems do have an opportunity that they just didn't have 5 or 10 years ago when Facebook really dominated the space. So I think that that's an important like thing to internalize as a developer is like, we always thought, oh, it'll never go away. It's going away, or it's becoming less useful to people. And it reminds me of some studies we did at Mozilla around desktop browser usage back in the day, where our conclusion was that over the last 10 or 15 years, it's not that desktop browser usage has lost users, but it's lost a density of usage to mobile, which makes sense when you think about it. And so that people will still have laptops or whatever, and they still do work on those laptops, but it's not a personal device and they don't use it all the time for everything. And just in the same way that people don't use Facebook all the time for everything anymore either. In fact, that's where they see their crazy uncle and his crazy ideas about whatever it is that he's talking about. And so they might be avoiding it and just going to the park and drinking beers instead. So
can confirm that's exactly my Facebook experience. Exactly. So let's start to wrap it up. We've got about 5 minutes left in the broadcast. And my sense is that we didn't really narrow in on the browser as much as I thought we were going to, but we did talk a lot about what the decentralized web's going to look like in the future, or the building blocks that get us along the way, including IPFS. We never did define IPNS, though. I wanted to come back to that. Bernhard, you used the term. What is it?
It's basically the gateway. And basically as
naming service, right? It's
yeah,
like DNS, domain naming service, interplanetary naming service.
Yeah, it is.
And as basically as Jeff alluded to, and there's a, it's currently not the most performant name resolution service in the constellation, and so there's actually another DNS resolver that's currently available. But literally, it basically what it does is it basically lets you use an HTTPS approach towards your CID addressing of that content. And just like DNS, I mean, things need to be resolved. There need to be references, there need to be lookups, and there need to be routes that the networks can figure out how to get there and how to get there most efficiently. And IPNS is one of those tools.
Great, thank you. And go ahead, Jeff.
And just like that, the other thing to think about is that DNS was originally designed to be a decentralized protocol as well. It's sort of like our original decentralized protocol. And domain names, in some senses, are somewhat decentralized as well. We have this web of trust. They've become centralized as a matter of practice, not as a matter of design.
Yeah. And you have alternatives in terms of Handbrake and Handshake, and there are some other ones in the Web3 space. So there itself is a lot happening. And once the confluence of all these efforts reach individually and collectively reaches maturity, I think you're really going to see things change. Sometimes I feel like if you look at Web2, we're at the, oh, look, there's CGI and we can like create a web page. It's like, oh, I mean, even though like when you're in it, this is like a big deal, right? Because CGI doesn't come off the shelf. You got to build it, and your HTML syntax is very limited, and so you got to build. There's in order to get the
pixels.
Yeah. So there's an enormous core contribution required to get a small result. Historically speaking, a small result. At the time, it's a huge result, but historically speaking. And there's so much happening right now that I really feel like a lot of things are about to bubble up within the next 2 years, maybe. And then you really sort of the downhill gradient's going to kick in, and you see hybrid solutions that bridge Web 2 and Web 3 in a lot, and that's going to be, in my opinion, the accelerant. I mean, Web 3 is going to go through the same motions. What Web 2 was with brick and mortar and web, I think Web 3 is going to go with Web 2 and Web 3, and it's going to be exciting times ahead, I think.
Totally agree.
Amazing. You just predicted that we're at the beginning of a transformation of the entire internet.
I truly believe it. Otherwise, I wouldn't be doing what I'm doing, and I certainly wouldn't be here.
I just wanted to put it in really clear terms in case anybody had fallen asleep by this time.
Still in the browser 3000.
Yeah, exactly. So in conclusion, I do want to call out to the people watching the YouTube video and probably on the podcast later. There is a link for feedback on this episode in the description there. Do follow that. We'll follow up with you. I think you get something nice. I'm not sure. This is the first time we're doing it. I'll become smarter on that later and clarify if there's a nice thing or not. But on the possibility of a nice thing, or just to be nice to us, please fill that out. And thank you, Jeff, and thank you, Bernhard, for this lively discussion. organized at the last minute, improvised brilliantly, and with great predictions about the groundswell of change that we're about to experience over the coming years due to the decentralized web, Web 3.0. Thank you so much. Join us next week for another episode that will be on the impact on our climate around computing, another episode looking in different aspects of that. I'll be your host. I will not have a new haircut. This one will have to do. See you then. Thank you so much. All right. Bye, guys.
Bye-bye.